Hello again. This is Roger Koch-Barr for the Bioelectricity course. We're in week 4 and this is segment 9. And here we want to review the changes that occur in the values of all of the state variables. Changes in N, M, and H, and changes in VM. Let's look at this process as a whole without so much detail to any one part. If we say we're going to change VM from one moment to the next moment, how will we do that? Well, saying again what we've said already, what we will do is first we will compute dVm according to this equation. dVm is dt times the membrane current minus the ionic current divided by Cm. We've discussed this above. Once we find dVm, we'll get a new value for Vm. A new value for Vm by taking the old value and adding the change. In that fashion, we'll have moved from our starting time to a new time, which here is designated time number 1. Let's look and see where the values came from that allowed us to make this shift. Im, in our case, is the stimulus current. So we know it because it is given to us, and in every situation it'll come from some outside effect. The ionic current, ion, the sum of the ionic currents, comes about by adding them up individually. So we use this equation to get the ionic currents. Cm, of course, is a constant for our tissue. Now if we back up again and we say, well, the ionic current is the sum of INA and IK and IL, where did they come from? Well, they come from N, M, and H, as well as Vm. So those values all go in there. So we use all of the values for all of the state variables, in getting to a new value for Vm. Now let's look at where we are as far as getting new values for N, M, and H. We do each one by the same pattern. We will get a value for D and dt using the process d and dt equals alpha n 1 minus n minus beta n times n. Then we will say n1 equals n, that is to say the old value of n plus dn. We can do the same thing for m and for h. But now look and see, let's see where these values come from. Here we're changing N, M, and H based on the equation that we have, alpha N, beta N, as well as the old value. And where do we get the alphas and the betas? We get the alphas and the betas because we know Vm. And Vm goes over here into the alpha formula. We were discussing that above. And then the alpha formula, the result comes down here to the value of alpha that's used for d and dt. So in getting new values of n, m, and h, we have to know the value of the other state variable, Vm. There's a certain kind of asymmetry here. We have to know the value of Vm to get new values of n, m, and h. And we have to know the value of n, m, and h to get a new value for Vm. It's an interwoven process, but it works, and it's amazingly powerful, both in the real tissue and in the calculation. But it's also complicated. and there are little cracks here and there where one can make an error. So to conclude this segment, I put in the picture of the sidewalk with cracks. Not to say that you'll slip between the cracks, either on the sidewalk or the calculation, but you do have to be careful to step over. Thank you for watching this segment. I will see you in the next one.